Okay, so this part, we'll be confined our discussions on this topic, that is content distribution, social media, and cloud computing. So they are highly related. So that's why I just, made it in a single part. And let's start with today's topic. So the content is appropriately this one. In multimedia content distributions, we will come across a concept of proxy caching and content distribution network and something called video on demand. And in this part, that is social media sharing, we'll see, user-generated content sharing and online social networking. And, this part is basically very well known to us because almost everybody of us are somehow related and using this social media sharing. And then lastly, we'll have this content, that is cloud computing for multimedia services. And we'll see, a brief overview on what is cloud computing and how this cloud can be useful for media sharing, that is from multimedia point of view, through an example. So let's start with content distributions, and the concept is basically proxy caching. Now, what is proxy caching? Proxy caching is caching frequently used data at proxies close to the clients. Okay, so it means that think about like this, that this is a client and this is our server, right? So the client is basically it likes to consume data from this server. The server has a media repository, and we like to consume the service. I mean, as you know that you are familiar with that, I explain those kind of things. So if there is a data, so I just the client just want to access this data somehow. But this server perhaps a long away from this client. So when it goes over the networks, it takes a lot of time, and it takes a lot of delay, those kind of things. So to overcome that, we use the concept of proxy caching. So what proxy caching do, in between the server and client, we just place some proxy server. Now proxy servers or proxy caching servers more appropriately. So in proxy caching server, what we had, between this server, in server we have media repository, and this proxy server, it has some sort of cache. And so what it does, so it basically see that, okay, this client, when it access some specific content, and then this cache basically this proxy server basically observes these communications between the client and servers, and based on their pattern, the most popular content basically cached in the cache server. So and next time when this client wants to consume some data, and if this data is already in the cache, so it doesn't need to access from the media server, right, original server. So in this way, it basically reduces the access time, and also because so it reduces the latency, that means the delay, and also it reduces the server network load in general. And also you see that because this data is this client is getting data from the nearby locations, so that means the transmission is more reliable, and there is less packet loss packet loss happens or data loss happens. So that's the idea what we use in proxy caching. So, and the protocol is a similar protocol, but this is some different kinds of things. So you can think of this media proxy is basically the broker between this server and this client. So server has a media repository, this is the original, and the client maintains some buffer, and in between we have cache, right? And from the client to proxy server, this kind of networks we say enterprise network, and from the proxy server and the original server, this is called backbone networks. So this is sometimes how we understand this. Okay, so now let's go with the concepts on content distribution networks. So what is the problem, or what is the issue with proxy caching? So caching is generally passive, right? So in the sense that when a user wants an object or a data at the times that data comes from the server, and a copy of that data basically keeps in the cache. So in other words, a proxy, it needs its own time to fill up the cache space, and there will be no benefit basically for the first user to access the data, right? Think about that. When at least this is maybe in the local in the area, there are maybe 5 client or 5 user, we can say one, and then maybe another user, and maybe another user, and another user, maybe in this area, in this, maybe you can say in our Seoul area, or maybe in a country, if it is a very global server. So it turns out that when this user access some content, and in the next times, if this user also access this content, then this user basically get the advantages, benefits, because this cache is this content that when the first user access already in the cache. But how about happening to the first user? First user generally doesn't get any advantages, right? And also this cache, to fill up this cache, it also needs a time, because first time and the second time, third time, when many users or maybe one user multiple times access the popular contents, so at that time this cache fill up. So to alleviate this problem, we come up with the concepts called content delivery network, or we can say content distribution networks, CDN. Now the CDN concept is very simple, that what we do is we have a very large geographically distributed systems of server, and they're deployed in data center across the internet. Or in another word, let's say this is in our globe. So what we do, we just keep some a replica server here, here and here and here, and maybe this is the main server. So from this original server, we basically copy the data, and we keep in different places around the globe, depending on your server capability and server service area. So this content server, so this is basically a network of your delivery server, and this is the original server. So and then if your client is maybe if our client is here, so maybe then it access from the data from this server, right, the nearest or closest one, this one. So that's the idea, right? This is called the concept of CDN. So this is an conceptual diagram. So this is basically the left one, that means this one. This is basically the traditional client server solutions that you have one server, and it has different kind of services or data, or maybe some videos they place on it, and then the client is basically accessing from the server, this client is from this server, this client is accessing data from this server. So this is a general traditional single server model. But in CDN model, that content distribution model, content distribution solution is basically this one. You see, this is our original server, and then the data is basically copied to this server and to this server and to this server. So we can say this server itself basically constitute a distribution network. So it is something like a logistic company, how logistic company, for example, in Seoul, Kupang, or maybe you can say Amazon, they have different kinds of warehouse at different places in the world, right? Or in Kupang, they have different kinds of warehouses in Korea, maybe in Busan, maybe in Seoul, maybe in Yongin, different places. And then when someone purchases some items, so from the nearest warehouse, that product goes on. The same models we deploy in content distribution networks. So that's the idea, okay? So this is a high level overview, and the view that how basically content distribution network works. And it is also similar to domain name systems, if you remember that. You see, this is a user, and this is basically in the local networks, and let's say it likes to consume some data from this server. This is basically the original server, and this gives the request that give me that. Definitely it means simply a URL, right, in a website address. And in response, maybe this original server just respond a very simple things. Maybe it gives you the index page of the website, and the other things it basically forwarded to the content distribution networks. And in the content distribution networks, there is something called mapping algorithms. It basically find out the mapping from the website address to the replica server. So it finds out that replica server, where the replica server is, and then it basically gives the instruction there. Then hey, you just give the content to that user, and then from the replica server it goes in, right? So as if you remember that it is a similarity with the domain name system, but that is the domain name resolution, but this is something with content request. So this is pretty much the everything that I explained. The step one, the user request content from the content provider by specifying its URL, and then step two is giving the decision onto the basic content, and rest of the content is coming from the CDN provider. CDN provider basically select the replica server, and then from the replica server we get the content. So the same things stepwise is here, so you can just go through it. Okay, now we understand something called this proxy caching concept and the concepts of content delivery network or CDN. Now see what they do. They basically explore or exploit or make use the concepts of something called temporal and geographical locality, right? So the CDN and proxy caching, they understand that maybe okay, these users basically, let's say these users, let's say 3 users, they are coming from this region, this area, right? And there is another area, maybe there is some other user here, and there is some other local area, maybe there are maybe 100 of users from here. So and then based on this pattern, so they understand okay, all of these users, they can be served from this server, replica server, and all of these users, they can be served from this kind of server, right? So they take advantage of these kinds of phenomena, that what's happening. Or maybe sometimes they understand that okay, all of these servers basically want to watch something at the same times, maybe at a particular time, right? So this kind of things happens. So and these sorts of things we can basically use for these kinds of purposes, for example, broadcasting or multicasting services. And what is, by the way, do you know that what is broadcasting and multicasting services? If you don't know, let's say I just explain this one first, okay? So for this, I just have these kind of things. So there are 3 kinds of actually casting. We say unicast, when you are just data communications happening from one particular source to one particular receiver or transmitter to receiver, or from a source to destination. This is called unicast. And the broadcast is you have a one source, and then you are basically transmitting the data from every possible receiver. So this is called broadcasting. And multicasting is maybe you are just sending maybe a group of receivers. This is the transmitter, and maybe this is the green, this is the group of receiver, only a selected number of receiver. This is called multicasting. So these concepts of this proxy caching and the CDN, they're basically good for broadcasting and multicasting services, right? Because we have let's say one replica server, and this one replica server, maybe this is a networks of content delivery networks, and this is one replica server, this is another replica server. So from this replica server, some users are being served. Maybe if it is a broadcasting, so or multicasting, so maybe one server, and then there are multiple clients, and this is okay, right? But how about, think about like this. If we think about something called media on demand, that is, media on demand means what? I like to watch some specific video at some particular time, or maybe other users want to watch the same video maybe at another time. So this kind of asynchronous. So that means they are not synchronous. They are not, that request is not happening. That demand is not coming at the same times. So so that means what? Then this broadcasting and multicasting can't serve the request at that kind of things, right? And even the same audio and video, and if there are 3 users, they want to watch some content, the same video at the 3 different times. So this kind of CDN and proxy caching perhaps is not good, right? So that's why we need something to handle this broadcasting and multicasting for video on demand, or maybe, or we more generally we say media on demand services. Not only just video on demand, basically media on demand, audio, video, and various other things. But most popular is basically video on demand, right? That I like to watch something at a very particular time, and that kind of things. So That's why I'm saying that among all of these possible, media on demand services, the most popular form is, video subscription, right? Maybe you just want to watch some very specific, TV program, or maybe, some specific video content, and you want at different time, right? At what time you want, and what time, at what content, so that kind of things. So ultimately, this kind of things, you need a two-way traffic, right? So in another word, user basically interact with the server, and server then gives, to the content to the service, right? So that's kind of, so two-way interactions. So this is the server and this is the client, and you basically on demand means at a particular, maybe you have the subscription from this server, you have the subscription of the servers, but you want to watch at a very particular time, right? So that's the things. But when you gives this, request, so that means what? You basically interact with through some interfaces, right? You select, and then you throw some sort of interface and applications, and then it goes in. So to do so, think about like a simple cable network. In cable network, you basically don't have any say. You just you change the channel, and you just watch something called maybe National Geography, or maybe CNN, those kind of TV, right? But when you allow this kind of two-way traffic, you basically need some sort of smart television, or maybe, or at least something called interactive television, so that you can interact with these interfaces, and then you can give that what kind of streaming service, or media multicasting or broadcasting or content you want. So most of the TV sets that we see in our home still today is basically simple. We have a TV monitor, right? So to allow this kinds of video on demand or media on demand service, you basically need some interfaces between your multimedia networks and your TV monitors, right? Or maybe some other interfaces, whatever it is. So basically you have a TV, and then with this, maybe not this smart TV, just simple TV, and you need some interface. So that interface is basically called set-top box. So ultimately this set-top box, providing, these kinds of two-way traffic protocols, service, right? So this two-way protocol service called set-top box, it basically, have the interfaces to the multimedia networks. It basically gives the network interface the communications that requires, and it also has the interface with the TV monitors, for example, this audio unit and the graphics unit, right? So audio video unit, the graphics unit, and definitely it has some processing unit. They do some buffering, and data goes in and out, and maybe some other kinds of interfaces you can have. Maybe this with set-top box you can connect to the IO devices, or some other kinds of a disk, maybe USB or something. So now you understand that why we need set-top box or STB. This is basically allowing some protocol support to consume some multimedia services. So that's the idea. But anyway, so we actually did not explain yet this broadcasting or multicasting video on demand, that we will be saying these things. The earlier we explained proxy caching and the content distribution networks, but it turns out that this is not useful when we are doing these kind of things for media on demand services. This is good simple general broadcasting or multicasting, but not for media on demand, right? And now to allow to happen this for the usual television that we see in our home, we basically provide this kind of set-top box, and now we are ready to interact with our service provider, right? Now when comes this, so how we can make available, how we can facilitate these kinds of video on demand, right? Video on demand means what? Each user, maybe different users basically coming up with a different request, and they want to watch different kinds of videos. So how this is possible? How this manage it? There are many kinds of protocols for that and the techniques. But here I'll be talking a very simple one that is called staggered broadcasting. And think about this is basically we are talking for the video on demand. Okay, let's say for this sake of example. Let's say we have a server that basically broadcast let's say m videos. Okay, there are m number of videos. So and let's say for this doing this to do so, this server basically let's say has a total bandwidth, let's say, there's certain amount of bandwidth, and that bandwidth is basically divided into, several channels. Let's say for this example, we just divided into 6 channels: channel 1, channel 2, channel 3, and channel 6. Now channel 1, what it does, it basically periodically, broadcast, all of this video. And let's say for this example, we have this server, let's say, have 8, videos. Okay. So just an example, eight number of videos. So this M is basically number of videos. So let's say, so in channel 1, it basically first, broadcast, this video 1, and then, for maybe, let's say for each one, let's say equal time period for this example. So maybe for L seconds, okay, L seconds or L minutes and whatever, it is a time period. So video number 1, and then the video number 2 is played in the next, L minutes or L seconds, and then video number 3 the next L minutes. So this is basically, time slots, right? You can say, think of time slot. This is for the video 1, and then video 2 playing, and the video 3, and up to video 8 playing, and each one basically L seconds or L units of time, and the L units of time I'm saying, and then 2, 3, 4, 7, and these kind of things. Now if we have M number of videos and each one requires L seconds, so that means total, time period, to broadcast that one is basically M multiplied by L unit of time. If L is in seconds or minutes, then accordingly ML minutes, something like that. Then when you finish this one, then again you basically start again number 1 video, number 2 video, number 3 video, number 4 video, number 5, 6, 7, in this way. Okay. And then so you just repeat in this pattern. Okay, you just repeat in this pattern. Now what's happening in the channel 2? The channel 2 is basically you just skip the first time period. Okay, the first time period, and you basically start from this place. So number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, right? This is here you finish. And then in the third channel, because all channel has equal bandwidth, because the total bandwidth has been divided into equal bandwidth, and then we are sharing into a number of channels. And then you just, what you do, so here you basically leave, you just leave 2 time slots, and then you start from here. So this is, again, the video number 1, 2, 3, 4, up to go in this way. And then in channel number 6. So in this way, you just, maybe leaves, maybe, I don't know, maybe 1, 2, 3, 4, 5, 6. So you just leaves, this 6, and then you starts, I don't know, is it right? Or maybe here, I'm not sure. You just check it exactly where it is, and then is a 1, 2, 3, 4, 5, 6, 7, 8, and this is repeat. So you just repeat in this way. So that means each channel is basically periodically broadcasting each video periodically, right? And similarly, so channel 1, channel 2, channel 3, channel 6. Now, do you get the idea? Now let's say at any particular time, let's say, I'm a user and I like to see, video number 3. Okay, video number 3, and perhaps maybe you can see that maybe the video number at least at any particular time instant. For example, let's say think about the very first 8. Okay, so at a very particular time instant, at least either I will get these channels or these channels or these channels. Out of these channels, out of this whole number of channels, I will see that very closest one, maybe which one is he starting. So in another word, at this time, at any time slots, basically I'm basically getting at least one of those video, right? So that's the idea, that how it does. Any users, if every user is getting the different video, basically he can either basically channel 1 or channel 2 or channel 3 or channel 6. So perhaps you saw that when you basically, for example, Netflix, when you go through and you like to watch some sorts of channel, some sort of video, when you click that, it basically takes some time. So that time it takes to get ready your content and access time. So but at least you will have to wait for this one time slot like this, right? Because that's the you don't know where you basically click, maybe here or maybe at this time or at this time. So maximum you'll have to wait up to this time period. So this is called access time, and these access times can be easily calculated. So this is your total numbers of time that you require to surf m number of video, and each one is L number second, and you just divided something called B. And what is B? B is basically called bandwidth ratio, and this bandwidth ratio we can obtain by just dividing the highest bandwidth divided by the what is your playback rate, that at what rate you are basically playing. So this, if you divide the W by B, this is basically bandwidth ratio, and if you just divide this one, this is basically access time for any video. Okay, so whatever video you want to watch, so you will wait maximum this kind of time, and after that you basically start the channel. So this is one of the, and why you are saying staggered, this is staggered in a sense that you just first give this time, and then basically you add up another time slot, and then you add up another time slot, and then you add up another same time slot. This sorts of accumulation is called staggering, right, one after another. So anyway, so this is a concept that how it is possible that this kind of video on demand broadcasting or multicasting. So there are some other methods called pyramid broadcasting, harmonic broadcasting, stream merging. So this is a very interesting concept, and this is also good. So you can basically watch something, and you can basically learn from yourself if you are interested. But just as a concept, this is staggered broadcasting is fine. Now let's something talk on called social media sharing. Okay, I mean, this is very much familiar to us, so I think I don't need to explain a lot of stuffs. So what's happened basically in traditional video on demand and live streaming services that we explained so far, so their videos are basically offered by some sort of some business people, right, some enterprise or some corporate. So there are some content providers, and so you basically so those content are basically stored in the server, and then as a user we basically subscribed to that contents and watch. So this is a traditional video on demand and live streaming services. But things have been changed a lot by user generated content sharing, or we say UGC sharing, and it's happened because something called UGC, right, that user content sharing. For example, think about YouTube, where users are basically producing the content and they're uploading in the servers, and they're publishing that one, and a huge content is coming. So it is a new phenomenon of content production circles. So and this YouTube is very much anybody, we are very well aware of this YouTube. And also the other paradigm is social networking. The social networking is also basically internet-based platform, so that people basically connect with each other through some social relations, maybe with friends, families, and whatnot, right? And sometimes some formal and various other kinds of uses is happening even lately. So very good examples of social media networking is Facebook and Twitter, right? Now providing this you already have good knowledge on that, but I'll be talking some different aspects of these things. Let's start with something called YouTube characteristics of YouTube video. So definitely these videos, this YouTube video that we see, it has very similar characteristics of traditional media server, but there are some substantial differences with YouTube like sites, right? Not only YouTube, I mean, there are many other kinds of site, but maybe YouTube is most dominating and popular, so that's why I'm just comparing with YouTube like sites, right? So one of the very distinguished characteristics of this YouTube video and traditional is video on demand or video on demand media servers is basically the length of the video, right? That, or maybe user access pattern. So anyway, so let's see some of the characteristics. So one characteristics like this, if we see the video categories of this YouTube video. So generally when you upload, maybe you have to select some category, and accordingly you can see entertainment categories, music category, comedy, people and blog, films, animation, sports, news and politics, education, science and technology, many, or maybe unavailable. You see that some videos are unavailable, right? And some videos are removed. Anyway, these are others. But generally, you have 15 categories. Perhaps you can check it the latest if it is changed or not. So we can see that most if you look about this percentage, that how much percentage for each category of video is a 25% video basically entertainment video, and 24% video, around 25% video is basically music. So, and all others is coming accordingly. But these are basically the top 4, right? Entertainment, music, comedy, peoples and blogs. So so this is how it is, right? So this is in terms of category, if you like to see. Now if we see other characteristics, so that is maybe the length of the video. So traditional servers that we see traditionally definitely it's a long video, maybe because usually those are movies, right? 1 hour to 2 hour movies. But YouTube content mostly comprises for short video, and it turns out that 98% of this YouTube video basically 5 minutes or less. 5 minutes or 600 second. 600 second means maybe I don't know how much. If you give 10 minutes or less, right? So 98% videos of that. And in fact, if you just do a simple statistical characterizations on that video length, if you just plot the video length in the x-axis and number of videos in the y-axis, and if you see in terms of the histogram, that it looks like this one, right? This kind of things. So so it says we can see the 3 primary peaks. So maybe one peak is here, and another peak is here, and another peak is here. So the first peak is basically within 1 minute, and it contains basically 20% of the videos, 20% of all YouTube videos, right? Okay, so in the second peak, you see this basically 3 and 4 minute durations, right? Because this 3 to 4 minute durations, and this contains basically another 17% of the videos. So that means 40% of the video is basically within 4 minutes, and 98% of the videos is basically within 10 minutes. So this is substantially, a very distinguishable characteristics between YouTube-like videos and, traditional on-demand or some media server, traditional, multimedia servers. And if we see the, characteristics, the length characteristics, or let's say length histograms of, top 4 categories, for example, this entertainment, music, comedy, and peoples and blogs. So you see the characteristics of entertainment video is characteristically the same as of overall videos, right? Because that what shape is following is exactly similar shape we follow in entertainment video. But for the music, it has basically high peaks around 3 to 4 minutes, as you see. So the high peak is basically around 3 to 4 minutes, and this is exactly look like the music length. So this makes sense, right? If you look at see a music, so it's basically 3 to 4 minutes. Usually a music sustained or the length of the music. So that's why the typical average length is music. And there are comedy is basically within 2 minutes, and then peoples and blogs is also within 2 minutes. And this is the comedy is basically 53%, and the peoples and blog is basically 41% of this video. I mean among these top categories, right? So these sometimes we can say mostly highlighting some clips, right? So highlighting types of clips. So that's some characteristics. Then let's say we talk about some other interesting characteristic. This is called small world characteristics. In fact, YouTube itself a world, right? This is we can see small world. In fact, this kind of social media, YouTube or Facebook, Twitter, we can think about this as a world, and then we can, for example, there is a LinkedIn service. So LinkedIn service, we see, or maybe let's say, generally in the physically, if you just analyze, the people's behavior or interactions and relationships, so that's called the networking phenomena, right? So the similar kind of networking phenomena we can we can see that what's happening in the YouTube itself, and we can see that there is strong correlation between number of videos and its top related videos. So if there is a top related number of views, how many views we can see for a video, basically it has highly correlated with its top related videos. So and this makes sense, and this basically allows more diversity on the videos of views, and it helps users to come up with more videos of their own interest rather than popular videos only. If we just rely on the popular videos, so every user basically consumes most of the popular videos, but we can see that what are the related videos, and then we can diversify the views, and so that's how it's happening, right? And if we let's say this one, basically this is basically this networks, we create a networks with based on the 1,000 videos and 1,000 we said nodes, and this was maybe 4,000 videos. If we just analyze that, and if we just generate this graph networks, that which video is related to what, and which video is related to what at what scales, and then if we just make some networks among them based on maybe the metadata, the tags, titles, and the description of the video that used in the video, and then we can construct these kinds of networks. And if you see this network itself, you see maybe there is some sort of cluster, and here is a cluster, here is a cluster. So this cluster behavior we can see. So that means, there are maybe some highly related, these are some highly related, these are some highly related, this is some highly related. And this is exactly also the world phenomena also in any aspect. So that's why this is called small world characteristics that, fits in with YouTube videos, right? And also, we can also, analyze that, the partner's view, that for example, when for example, when as a YouTube users, you just watch a particular video, you basically reach to that YouTube video through different ways, right? There are different kinds of path that you basically refer to that YouTube video. Now this is called the last web page, where the viewers basically come from. It is called a referral source. Maybe you are using Facebook, and from the Facebook someone shared a YouTube link. You basically click that YouTube link and go to the YouTube video. That's called the referral sources, right? Now understanding these referral sources for the YouTube is very, very crucial for the partners. So basically, that you have a company, and if you understand that how referral sites working, that you put in how much money you will be giving for the advertisement in the YouTube, so that kind of things. So this is some sort of analysis that we find based on a very particular example. And let's say this is a breakdown for the referral sources. Okay, so for example, let's say channel A, the YouTube channel, and let's say that there is another channel B, this is another channel C, and we can see that how the referral sources work. So think about this channel A. So it seems that this channel A, 35% referral is basically coming from the suggestion. Suggestion means when you watch a video and there is some recommended video, the suggestion related video, so that's called the suggestion. And 31% referral is coming through searching. That means you basically search through search engine Google, or maybe from the YouTube searching. And then some maybe 16% is a very substantial percent coming from the surfing. Surfing maybe someone is recommending, or maybe you are seeing from a advertising things or promotional things. So this is called surfing. And then maybe it's coming from the social media, and maybe something coming non-social media that is unknown, right? So this is how it works. So this kind of analysis is also helpful to decide something for your company, that how it works. Now we finish those kind of things. Now let's see some things on cloud computing and how it's related to our multimedia. Now what is cloud computing? You see, cloud computing is basically we have internet, and through the internet we basically want that we are user PC, laptop, smartphone, or tablet. We basically want to use some service, for example storage service, right, hosting service, or maybe computation service through some sort of cloud provider, right? So for example, you just like to save your data not in your laptop, but you save your data maybe in the storage itself, right? Maybe in the Google storage, Google storage. So Google has a storage service basically. So this is a kind of cloud provider, storage provider. Or maybe in another sense, maybe you like to do some video editing, but we basically don't want to do all this editing computation here. You just give the command to the server in the provider, and basically all the computation is done in the server, and then you basically after done you just take the content back, right? Edited content back. So that's the called the cloud computing. So, and I can give you an example that what is the cloud computing, and that is even actually very good, the cloud computing. The idea is, think about like that. Let's say you have some party tomorrow at your home. The party may be birthday party or some sort of wedding ceremony. So what you do, maybe you need 100 chairs or some furnitures for your party, right? And that means the people from many peoples and guests will be coming, your friends and relatives. So where they will be sitting, so you need thousands of chairs, or maybe you need maybe 20 or 30 cars, private cars, or maybe SUV cars. Then how what you do it? You basically buy this 1,000 chairs or maybe 100 of cars, or basically you go and you rent. So which one is good? Of course, renting is good, right? So that's the idea, that you basically rent it, and after you use it, basically give it back. So similarly, maybe for some reason you need a huge computation power or maybe huge storage. So what you do, you basically go for some cloud provider, and then you just use it for one day or for some time, and then you just finish. You just pay for a small amount of money. So what this cloud provider do, they basically buys lots of servers, lots of computing, big machines, and they keep it in some warehouse, data centers, and just you use it, right? Every people use it. So that's the idea of cloud computing. Now this cloud computing gives three different kinds of services according to service models, and there are three different kinds of service models. Now this is called infrastructure as a service, platform as a service, or software as a service. Infrastructure as a service, or maybe we say IaaS, and platform as a service we say PaaS, and the software as a service we say SaaS. Okay. Now I will give you a very brief explanation that what are the differences between those IaaS, PaaS, and SaaS, and it will be helpful for you even to understand and utilize this knowledge in somewhere else. Think about what is IaaS. Now before you understand that one, think about that you have a software company or IT firm, and what you do, maybe everything you manage on yourself. You have your IT office or we say premises. You do everything, you manage everything yourself. For example, in networking, where your data will be stored, your servers, and maybe if you use some sort of virtualizations, this virtualization, you have your own operating systems, or maybe you maintain your own security, and you basically when you run all of your coding and applications in this runtime is also you do it yourself, and your data, your applications, everything do yourself. You manage yourself everything. So this is called on premises. You have your own laptops, own computers, own servers, own networking, own storage, own data center, virtualization, OS, everything in you. But how about maybe you just don't want this everything do but yourself. Think about, let's say, then for the networking, storage, and servers, and let's say up to virtualizations. Okay, maybe this kind of things you basically do outsourcing. That okay, I will do these things. I will develop my applications with my own data, and I will run it. I will maintain security. I have my own operating systems, but everything else basically I will be giving to somewhere else. Okay, some other party manages these things for you. So you basically use someone else networking, storage, servers, and virtualizations, and you do it yourself. So this is called something called infrastructure. So infrastructure as a service. And when you use some other people's infrastructure, you just pay something, right? So that's an infrastructure as a service. Now you may think of, no, I even don't want operating systems. I don't want this. I don't want to manage this middleware, or this is security, or some sort of patch or some update. I don't want to even maintain the runtime. Okay, I just have my own programming and coding. I have my just own data, and everything else I will run on some other middleware, other operating system, virtualization, those things. So this is called platform as a service. So basically you have your own applications, own data, and you run everything on some other kinds of things. So this is called platform as a service. And there are some other paradigms. You basically don't want to do anything. You basically just have your data. You basically pass this data, and that's called software. The software is ready. That will be run on other servers, managed by the security patch will be provided by service provider, operating system, virtualization, server, storage, everything. Network is from somewhere else. So you just put your data, give your data, and everything done automatically. So this is called software as a service. So we as a personal user, basically mostly we rely on the software as a service, right? So this is what is the differences between IaaS, PaaS, and SaaS. I hope that it will be helpful for you. Okay. So this green color mean you manage, and this mean other manage. And there are some examples if you are just interested in that. So for example, example of SaaS is basically Dropbox. We use Dropbox, so or maybe WebEx. So this is basically SaaS, software as a service. So and infrastructure as a service, maybe Amazon Web Service, AWS, and this is some examples of the PaaS. Now, for the multimedia, stuffs, multimedia sharing, one very good example. I mean, what I'm explaining now, that we understand the cloud concept, and based on this cloud, how we can utilize this in media sharing or multimedia sharing. Now, one very good example and very powerful examples is basically Netflix. So Netflix basically, now everything basically they manage their applications, that their media sharing, via cloud service, and this is exactly via Amazon cloud service. Okay, so a little background: the Netflix basically they started their business in 1997. So at that time, basically their core business was selling DVD, and the DVD was basically you as a service, the customers, they used to write to them that, hey, I need the DVD, and then DVD was mailed by the Amazon. Okay, and then so this was the case, and this is basically the things in 97 they basically used that one, and in 2007 they started introducing video on demand via the internet, because internet became popular at the time. And later in 2008 they basically suffered from storage data corruptions and some other kinds of troubles providing this video on demand service, because their server was not strong. So then 2009 came, and Netflix started using Amazon's AWS, Amazon Web Service. So that means all the things that Amazon did, and Netflix did, they basically relies on the Amazon servers. So this is very interesting things. And in 2012, they completely shift their technology infrastructure to Amazon, AWS. This is Amazon Web Service. And this is some example. Netflix, what they do, basically they purchase the master copies from the producers and maybe studios, and this master's copy is basically copied and then converted to a different versions based on the different quality, audio quality, video quality, based on different kinds of customers' requirement, right? And then those copies basically uploaded in different Amazon AWS. So that means this is basically Amazon network, everything they do. And this Amazon, so Netflix also use, the content, delivery networks. This is also, again, is basically, provided by Amazon, servers, right? So what Netflix is do, they only, do the registration and payment. Netflix has just a small server. Of course, this small server is also big server. They basically only maintain, their own registration and payment, and everything else basically, done by this, relies on this Amazon AWS. So this is, how, cloud itself, can assist, these kinds of, media sharing, and even the big players are using basically other big players, cloud computing service, right? So I hope that you understand these things. So, okay, so I'll see you next week.